Financial Modeling, Topic 11, Default Adjusted Bond Returns, Section 2. We're going to create a two-period model to compute the default adjusted bond return. So we've taken the transition matrix from Topic 1 and I put it into a spreadsheet. We'll grab that spreadsheet, and here are default probabilities based on the initial rating and the rating at the end of the year. And what we're going to do is talk about a B-rated bond. What is the probability that a B-rated bond will default within 2 years? Again, this is a one-year transition matrix. So a firm that starts out the year as a single B rating has a 3.9% chance of defaulting in 1 year. Question is, what is the probability it defaults in 2 years? And the answer is it's not 2 times that number, because we have to look at the probabilities that that B-rated bond could be upgraded, downgraded, and default within both years. So it's a little more complicated. Based on these number of ratings, there are 8 ways for this bond to die within 8 years. 8 ways of this bond to die in 2 years. Let's say, again, under these 8 scenarios, this bond starts off with a B rating. At the end of 1 year, that bond, in theory, could have any rating, including default. Now, if I'm looking at the 8 scenarios in which this bond dies, it could start out at a B. At the end of the first year, it could be any of these ratings. And if we're only looking at the paths in which it dies, at the end of year 2, it would be in default. So let's look at the most, say, likely default probability. A B-rated bond is a rated B today, defaults next year, remains in default. Another highly probable event might be that a B-rated firm gets downgraded in the first year and then goes into default. Another highly probable is that a B-rated firm remains a B at 1 year and then goes into default. Let's look at a really improbable scenario. A B-rated firm gets upgraded to a AAA, then dies. So how we calculate the probability of all these possible paths to death for this bond? Well, first take the probabilities that a B-rated bond winds up at any of these ratings, which is actually this row right here. So I'm going to just select this entire range here, say equals transpose. I'll select that row, close, Control-Shift-Enter. So I've entered that row as a column. So these are the probabilities of going from this initial rating to these ratings. Now, what's the probability that the bond that's in these initial ratings, in other words these, wind up defaulting by the end of 1 year? This is now the second year. Actually, that's this column right here. So I'm just going to have a link here to these default probabilities. So now I just need a joint probability for every path. Let's start down here. There's a 3.9% chance the B-rated bond will die in the first year, and a 100% chance it'll remain in default. Bonds don't get better. And then I can copy this formula up. There's a 3.44% chance a B-rated bond gets downgraded to a C-rated bond. And then a C-rated bond has a 13.6% chance it defaults. That joint probability is 3.44 times 13.6. So these are all the joint probabilities of bonds dying within a B-rated bond dying in 2 years. If I sum up all those probabilities, there's a 7.78% chance this B-rated bond will default in 2 years. If I take the 7.78 and subtract the 3.9%, there's a 3.88% chance that this B-rated bond dies or defaults in the second year. So this is a conditional probability. If it survives year 1, there's a 3.88% chance, not 3.9, that it dies in year 2. And that's largely coming from the fact that there's a fair chance that it gets upgraded versus downgraded. Actually, a B-rated bond, if we look at this data here, there's some pretty high probabilities that that B-rated bond does get upgraded. And then if it does get upgraded, there's a very low chance of it going into default. So that's why this is a little bit less than just doubling the 390. So that's how we can calculate the probability of a B-rated bond defaulting in 2 years using a 1-year transition matrix. So let's talk about the expected return of a B-rated bond. To calculate the expected return, the default adjusted expected return, we need to calculate the expected cash flow at every time period, every coupon and par principal period. And how we do that is we say there's going to be 3 possible states at every payment date. Those 3 states are the bond goes in default at that payment date. And that's going to be equal to the probability that the bond defaults in that period times the recovery of the bond, which is its par times the recovery rate. Remember, if the par of a bond is, say, $100 and the recovery rate is 50%, there's some probability that the bond defaults and you get that $50 back. So if it goes in default, we need the probability of default in every period times its par times recovery, or plus its times its par times recovery. At period T, if the bond remains solvent, it has not defaulted, what we do is calculate the probability it has not defaulted, which is 1 minus the probability that it's defaulted prior, times whatever the promised cash flow is, either the par and coupon or just the coupon. And then last, what if it already defaulted in a prior period, or it's already matured? In that case, the cash flow is 0. So we have to always account for the probability it defaults now, and in that case, get the recovery times the par. The probability that it has not defaulted and is not defaulting this period, in that case, you just get the promised cash flow. And the probability it's already defaulted, in which case you get 0. So let's build a little model to calculate the expected return of a bond that has a par or face amount of $100. It's selling for $90, that's my price, has a 10% coupon, makes 1 payment per year, maturity of 2 years, it's currently B-rated bond, that's the one we've been talking about up here, and there's a recovery of 50% in default. So let's go build a little spreadsheet to calculate the expected return and YTM of this bond. Coming down a little lower in our spreadsheet, let's get the promised cash flows of this bond. If we buy this bond today, we'll pay $90 for it. And in 1 year, we're going to get 100 times the coupon rate. We'll get the first coupon payment. And in year 2, this 2-year bond will get that coupon, I'll just add it, plus the par face amount. So these are the contractual cash flows for this 10% 2-year bond that's selling for $90. If I simply take the IRR of the promised or contractual cash flows, that is the YTM of this bond. That's the yield to maturity. But in some sense, it's the best case scenario. In other words, if this bond does not default, I will earn $16.25, with the caveat that I'm able to reinvest this coupon at $16.25. Now let's talk about the expected cash flow. I'm going to pay $90 no matter what. Now I need to figure out what is the expected cash flow 1 year from today and 2 years from today for this bond. To do that, I need to know the probability that the bond defaults in any given year. So the probability that this B-rated bond defaults in the first year, we already calculated that. That's the 3.9%. And that's based on the 1-year transition matrix. The probability of this bond defaults in the second year, we've already determined that that's 3.88%. That's that conditional probability that the bond defaults in year 2. We now need to calculate the probability that the bond survives year 1. That's going to be 1 minus 3.9. And the probability the bond survives both years. That's 1 minus 388 minus 399. So that's the cumulative survival probability. And lastly, let's calculate if the bond defaults in any given year, 1 or 2, what do you get? You get the recovery rate times the par or face amount. That's your $50. So in year 1, there's a 3.9% chance that this bond defaults and you get $50. And there's a 96% chance this bond survives and you get the promised cash flow of $10. So it's a 3.9% chance of getting 50 and a 96.1% chance of getting 10. There's my two cash flows times their probabilities. So the expected cash flow in period 1 for this B-rated bond is 1156, which is actually counterintuitive, right? This bond has a coupon payment of 10. However, once you factor in the probability of default, the expected cash flow in 1 year is 1156 because it's 96% chance of getting 10, and then the 3.9% chance of getting 50, but then you get 0 afterwards. Let's copy this formula. In period 2, there's a 3.88% chance you get 110. I'm sorry, you get 50. There's a 3.88% chance this bond defaults in year 2, and you get recovery. There's a 92% chance you get the 110. So the expected cash flow in period 2 is now less than the promised cash flow, because it may have died earlier, is 103. If I take the IRR of those expected cash flows, I get 1379. That is the expected return of this bond. It is not 1625. 1625 is simply the yield to maturity or return if the bond does not default. So that's the intuition of how to calculate default adjusted bond return. I need the probability of a bond defaulting in every given year, even if this were a 30-year bond, and I need to know the cash flow in default or its recovery rate. So in this topic, we calculated a 2-year model to compute default adjusted bond returns. In the next topic, we'll use matrix algebra to create an end period transition matrix, and the last section will create an end period default adjusted bond return model.